Hello, everyone. I think we're live, so we're good to go. Great. So, in this session, I want to talk about something that I think has been sadly neglected, and that's the issue of simplicity in cloud systems. Now, when I'm talking about simplicity, people tend to think that I'm talking about simple, unsophisticated solutions, and that's not quite the point. The issue is that many times I see people who are jumping into very complex solutions specifically in order to handle scenarios that they may not have. And the classic example is, oh, I want to build a, a simple business application. But in order to build that, I have to take on myself infrastructure that is meant to support uh, application at Google scale, at Facebook scale, those sort of things. And the problem here is that then you're mostly spending your time not on adding business value to the system, but just managing the complexity, most of which is completely unnecessary. So I want to give you a simple scenario. My name is Oren Eini. I have been building a database called RavenDB for the past, I don't know, 12, 13 years. A few years ago, we had a requirement. Customer came and told us we want to run you on the cloud, and we want you to run that. So we had to build a DB as a service in the cloud. Now, I build RavenDB for a living, and we absolutely support it on the cloud, but now we had to run it ourselves. So we started to look at what are the typical configuration and deployment options that we had. And that was a decidedly non-trivial issue. But we had effectively two teams working on that. One team went into the let's see what is the most recommended best approach to building something like that. And the other team went into I want to do as little as possible to get a product out. And the way that it worked was that we let those teams run for a while and then we saw what's going on with it. And that was actually quite exciting because we got to play with technologies that we typically don't do. RavenDB is a distributed NoSQL database, but for the most part, we can assume nothing about our environment. And in the cloud, one of the most powerful features that you have is that you can actually make assumptions. You can say, oh, I know that we're going to use this type of machine. I know that we're going to have this type of network, those sort of things. And that was very free from our perspective because, oh, suddenly I can make assumptions and make them stick. The story of this presentation is that I want to show you the decision process and the manner in which we build RavenDB cloud offering. Uh, Here's a problem. We go to the cloud, we say, okay, we want to run our service there. That's an actual issue because I have no idea how to get started. At last count, AWS had 300 plus services, any of which might be relevant to our needs. And just navigating that is hugely expensive proposition. Now, we also had a hard requirement. We have to run this on multiple cloud providers. Each one of them is slightly different services, different processes, all sorts of stuff like that. Now, one of the key features, I mean, we are providing the software, but the backend of the any cloud offering is about the management, the monitoring, what's going on, all sorts of stuff like that. And finally, from the perspective of our administration, from the perspective of our team, we wanted to have a consistent experience. I don't want, oh, this customer is running on AWS, we have to go that way. Or this customer going on Azure, we have to do things that way. So we wanted to have an overall consistent experience across all of the clouds. Currently, by the way, we are supporting AWS, GCP, and Azure, but IBM and Alibaba are fairly strong, and we might want to support them as well. So, and the differences between even the three major cloud providers is still huge. So, how do we manage that? How do we manage the those changes between the cloud provider? And there is a simple answer for that. There is Kubernetes. That's what it's for. So the whole idea is that we can now abstract all of the cloud infrastructure, all of the things that we need into a YAML file, and that's about it. And when we started looking at Kubernetes as a whole, we realized that there are quite a lot of really interesting features here. The resource allocations, the automatic recoveries, all of the other tools that we have are just really nice. The fact that I can do rolling update like that, well, not like that, but you know the point, is quite nice. We also have another issue, or another benefit here, is that we already support running on Kubernetes. So that makes things easy, right? And what's the problem with Kubernetes then? Why not just use that and that's it? And the answer is that this is horrendously complex. And I don't think that even the most advanced supporter of Kubernetes can say that this is not complex. There are a lot of moving pieces. There are so many complexities that you have to manage because Kubernetes gives you just the schedule of the nodes, of picking them. Everything else is ingress controller, DNS, secrets, blah, blah, blah. A whole bunch of other stuff that you have to understand and work with. Now, just to give you some small example. RavenDB uses two protocols for communications. One of them is HTTPS, and that's easy, very nice to work with. And the other one is an internal TCP-based protocol. Well, you know what? You cannot do that with Kubernetes. It can't do routing based on host and port, only based on the host. And RavenDB uses certificate authentication, which means that you have to configure SSL pass-through and a bunch of other stuff like that. All of which are things that we have solved. We are running RavenDB on Kubernetes, but then we realized that all of those things also came with a huge cost to them. Management, monitoring, and troubleshooting costs using Kubernetes were extremely high. Oh, this node can connect to this other node. Why is that? And then you have to figure out on the routing inside Kubernetes, the firewall between the physical machines or the virtual machines, and whatever the pods are aligned according to the phase of the moon and all sorts of stuff like that. So that was something that we wanted to avoid. And again, we solved them. But now we realized that when we solved running on Kubernetes, we solved them in a particular context. We solve them when we are running inside the same scope. You as a user is running Kubernetes and you want to run RavenDB inside your Kubernetes cluster. That's solved. That's problem. That's no problem. When we want to talk about DB as a service, we have to take into account that we have different tenants and we need to have very strong isolation between them. Just the thought of one customer being able to somehow peek into the database of another give me the shivers. So we have to have very strong isolation. We also need to be able to monitor what's going on in a single particular pod, single particular instance, regardless of all of the other instances that we have. And that leads us to another issue. And that issue is that uh, Kubernetes in general does a good job of isolating memory and CPU. But RavenDB is a database, and database needs to also manage I/O, and Kubernetes has very few answers in that regard. There is also the critical issue of security. Ideally, in a situation like this, I want to run all of my RavenDB nodes across different customers on a single Kubernetes cluster. It's cheaper, it allows me to have much better resource utilization because I can pack more pods into a single virtual machine. But there is an issue here. And the issue here is that RavenDB allows administrators to execute code. And that's a feature. That's a feature of RavenDB. You have the ability to apply code as part of your processing of the data. Effectively, however, that means that if we give a user administrator privileges on a database, they have code execution privileges. And that means that going from, oh, I have an admin privileges on my instance to owning the machine isn't that hard. And it's not even that complex. All you have to do is find a local, RavenDB is running as a standard user, but you can find a local privilege escalation, and those tends to be considered less severe. But from our perspective, you are owning a RavenDB instance, then you own the pod, and then you escape from the pod and on the machine, and then you're able to see other people's data. And that's a huge impact. So there's also another issue. There is the Spectre and Meltdown that came out in 2018, I think. Those are speculative execution and side effect timing attacks on low-level CPU details. Now, just to give you some idea, that single article, that single set of discoveries about Meltdown and Spectre resulted in about 10% reduction in cloud performance. Why? Because a lot of mitigations had to be applied to prevent users moving between being able to effectively break all of the expected barriers. Spectre allowed a JavaScript code to have arbitrary read permissions on anything else. And you could use it to bypass kernel mode and a bunch of other stuff. Now, there's also, as recently as this month, another paper was published. I see that micro-ops. So again, leaking secrets, that's a huge problem. I don't want to be on the hook for that. So there are also other issues. If it's typical for people who want to run on databases. Oh, I want to have a VPN peering, so only my internal system will be able to access that. But if I'm running multiple pods on the same machine, there isn't a good way for me to handle that. How do I manage audit logs? How do I manage access to a particular tenant on a particular node without doing all of that? And again, a single container escape bug can kill us. So we need something else. And then there was this fun. This was when we talk about the cloud, we tend to talk about things like security, things like performance, but if you want to build the cloud service, billing is an acute problem. And it's a really complex system. Now, the cloud would charge you for anything. If they could charge you for the number of breaths that you take while looking at the website, I'm assuming that they would. And the problem then is that if you're running a cloud service that is sitting on top of another cloud infrastructure, You have to have some way of either absorbing those costs or reflecting them to the customer. And the simplest scenario is what happened when we are talking about data transfer charges. If I have a user who suddenly decided that, oh, I want to load a very big document on every call, and I'm going to do that from a remote data center, they can burn through a lot of bandwidth, and then we would be charged for that. Now, if I'm running in a system where I'm running everything inside pods, how do I correlate the charges to the relevant customer? Even if each pod is running on an independent, on a one machine, because the big one would run on a single machine, but the small ones would tend to run on, we would tend to pack them on multiple pods on the same machine for better utilization. So that makes it really complex to try to figure it out. And that's, you don't want to get, oh, this machine costs us $15,000. It has three tenants on it, 500 each. That's not something that you can do. Uh, on Azure, you're charged per storage transaction. And that means that you have a problem. Because think about that. If I'm running multiple customers on the same disk, how do I assign which one of them is costing me that money? So we started thinking, this is really, really complex. This is really way too complex. So though there are solutions, by the way. There are things that you can try to do, but you have to become an expert in Kubernetes. And honestly, that's not something that I want to do. The thing that I do, I build databases for a living. Understanding the internals of how to manage Kubernetes and all of its complexity, that's someone else's job. 1 second. I'm speaking. So I got noticed that the live feed is disconnected. Let's see if that would go on. Okay. So anyway, to continue. Uh, 1 second. Let's see. Okay. Uh, I'm assuming that you can at least hear me, and I will continue. So the complexity of using Kubernetes to manage cloud infrastructure in this manner is quite high. So as I was saying, complexity is too complex. The complexity of using Kubernetes in this context was too high and required us to have a lot of expertise both in how Kubernetes is built and uh, dealing with a lot of non-trivial issues. The security and billing issues were the hardest to resolve. And then we had the share access. I talked about this just a little bit. CPU and memory are managed by Kubernetes, but IO isn't. So one of the things that we you would typically have in a database product is the number of IOPS that are available to the instances. So what do? If you have a shared disk, then you have to have some way of controlling that. And again, in shared disk, in Azure at least, you're paying for the number of IO transactions that you have. If you have separate disk for each customer instance, then there are limits on for per instance type on the cloud for how many disks you can add. All of which ends up being an incredibly complex system to manage. The number of variables is too damn high. So then we started looking at the other side, the other team. And the other team said, I don't want to deal with any of those issues. Kubernetes has nice offerings, but I don't actually need a lot of that. RavenDB is already a distributed system. And what I actually need to get running is a machine, set up network connectivity, set up the RavenDB instance, and that's about it. And now that's not really all about it, but it actually almost is. There are certain things that we still need to do. I need to scale up and down. I need more CPU for this machine. I need more disk for that machine, those sort of things. But the question then becomes, how do I manage that? And do I need to have something like Kubernetes to manage that for me? And think about that. That's not really the case. So in concept, I need to create an instance with specific resources. I need to configure the firewall rules, and I need to install RavenDB. And you can see here, here is how you do that. AWS EC2 run instances, give it an image, connect to that, connect to the running instance that we just deployed, and run a setup script, or set up or use the or have a already prepared image that you can just deploy. And the interesting thing about this is that a lot of the things that I thought I'm going to need from Kubernetes are things that I already get directly from the cloud. What do I need from the cloud? Give me a machine to run on, set up the network so I can talk to the different nodes in the cluster, and I can talk to the different node in the cluster and to the different and to the actual users. That's about it. Now, if this is all I want, that's the baseline requirement for the cloud. I'm already multi-cloud in here. Sure, I have to have somewhat different API for each of the providers, but this is basically all I want. And this is funny because we're going to the most common denominator, which is the least common denominator. But we need the lowest level. We just need a machine and network. From there, everything is based on RavenDB itself, which is already a distributed system. So I want to see what are the impact of that. We have isolation between users, a very hard isolation between users, because okay, a user may own the machine. Who cares? It's their machine. Worst case scenario, they mess up their machine. I don't care about that. There is no security breach here. Worst case, a this is the issue of rating a support call. VPC, peering, all of those sort of things, VPN access, I can just do that. And I have strong isolation at the network layer. I can set up access logs at the machine level quite easily on the cloud. If I have to raise a support issue to the cloud provider, and that is a very important consideration. Let's say that I'm running a machine and I'm saying, I'm running an instance, I'm saying, hey, I'm seeing very high network latency. Why is that? If I'm running this on a machine that has 8 different instances, there is a lot of noise around. If it's that particular machine that is doing that, it makes things a lot easier. In terms of billing, the cloud does all the work because the cloud already give me the associated level on a per instance basis. All I need to do is says, okay, instance XYZ was owned by customer B. He gets all of the charges for that. It also means that in many respects, I can reflect all of the cloud monitoring abilities directly to the user. I don't need to try to figure out how to monitor a pod or how, and again, CPU and memory is easy, but how do I monitor IO consumption? And in here, it just works. A lot of the things just become so much easier in this regard. Now, it's interesting because I'm not actually doing anything. And that's funny. I'm not actually doing anything. I'm relying on the cloud provider to do all of the heavy lifting. And this is being lazy, which is another way of saying that we're being very smart. We have vastly reduced dependencies. We have a lot easier model to work with. If I'm bringing a new cloud ops teams, cloud ops team member to my team, and I tell them, oh, this is the way that we go, there is not a lot of complexity to explain. They already know most of that. Now, that also has some interesting implications. We started building that on AWS, and then we wanted to support Azure. So I basically took a weekend, and by the end of the weekend, we had the service running on Azure because we were not expecting much from the cloud. That also has other impacts. If we're using the base level things that we need, it also means that we can go for the cheapest rates. We're not doing much. Think about it. If you're looking at AWS and you said, okay, how much do I get charged for Kubernetes, for pods, for those sort of things? You pay the premium. If you're running on the bare metal, on the baseline VMs, the instance types, this is the cheapest you can go. So, but now let's talk about the moving from the baby mode to more interesting scenarios. I need to manage things such as dynamically scale. Oh, I'm facing a Black Friday event. I want to have more resources to my system. Well, let's say that I have a 3 node cluster and I'm running that on an instance that has 2 cores and 8 GB of RAM. What I need to do is pick a node in the cluster, shut it down, change the instance type to have 4, 8 cores, 32, 64 GB of RAM, and start it up again. Once the new node is up, I can move to the new one. So because RabbitMQ is a distributed system which expect failure, I'm able to do those sorts of things quite easily. Bring down a node, the cluster adjusts, update the node, and move on. It just happens. Think about it, the entire process of upgrading or downgrading the capacities of the cluster takes very little time. 5 to 15 minutes. 5 minutes on AWS, 15 minutes on Azure if the stars aren't aligned properly. That's nothing. And that's a trivial thing to have. And during this entire time, the user is unaware that this is happening because the software already does all of the failover in the background. So in the same manner, I want to update the RevenDB software. I want to apply patches to the OS. Go into the instance, shut down whatever you need to shut down, do whatever work you need to do, start it up again, move to the next one. Those are automatic rolling updates. Now, I do want to mention something here. This is not that easy. Well, it is that easy, but you have to build a control plane. Someone needs to do those for each operations, and you need to something that would translate the or deploy an instance to an actual cloud command. But it's not that hard. It's seriously not that hard. I mean, think about it. Create an instance. Okay, in AWS, this is one API. In Azure, it's another API. Sure, I don't have the exact instance type across each one of them. Sure, the IO subsystems between GCP, AWS, and Azure are completely different. But I can map between them on a fairly predictable manner as you get it. And to be honest, there's not much that we have to do. Now, this gets more interesting once we start talking about how do you do non-trivial operations. For example, let's say that I want to increase the disk volume. Kubernetes has support for that. Think about it. Kubernetes has support for that. In 2018, we actually, at the time that we started Revenue on the cloud, I don't think Kubernetes had this support. But you can try and figure this out. I will leave it an exercise to the watcher because I wasn't unable to follow all of the things that we had to do. But on all of the cloud platforms, shut down the instance, go to the volume, increase it, start the instance, run resize to FS. That's about it. That's about it. And it goes even crazier when you realize that there is a big note here on no special knowledge required. Whenever I have an issue, whenever I need to do something, I don't need to solve how do I do this issue in Kubernetes. I have to solve how do I solve this issue, period. That's it. And that's a vastly simpler option. Now, a lot of that comes because we are already distributed. We're already managing our own systems. A lot of that also comes from the fact that when I'm talking about a cluster, a customer comes to me and says, I want a RavenV cluster. So I'm going to go ahead and deploy that to any number of machines that they want. I'm setting up RavenV to connect between of these machines. I'm setting up the relevant firewall, and then I'm done, effectively. I want to move up or down in terms of capacity. I can just use the native cloud tooling for that. It's also much easier to work with because it means that, oh, you know what? I can do a whole bunch of interesting features. For example, all of the cloud provider offer things such as uh, NVMe instances, which have transient disks. I'm a database. I can't have transient disks, but I can make it work with RavenDB because I can set up multiple nodes in different availability zones and just have it run this way. One node failed, I just restarted. It start in a fail mode and recover from the other nodes in the cluster. That makes things simpler. I can use all of the advanced features in the cloud. Now, that's I think the most important takeaway from my my session. Simplicity doesn't mean unsophisticated. Simplicity means that we looked at the set of problems that we have to solve. We looked at the solutions that are for the problem set, and then we realized that what I need to do, what I need to manage, is to have it workable, to have the complexity manageable. Now, I think that we have hundreds, thousands of instances right now running across multiple clouds, and that's interesting. That's interesting because I don't feel the weight of that. I'm not managing a Kubernetes cluster with 800 nodes in US East, for example. I'm managing a lot of independent clusters which demand very little management overhead for me. It means that across the boards, my overheads are much lower. My support burden, both direct and cloud support. By direct, I mean a customer comes to me and says, I have a problem. I can access the instance and figure out what's going on. I can call the Azure support and hey, I have a problem with this instance. For that matter, I can reflect a lot of details to the customer because they're running on their own instance. They have access to the whole thing. For example, if I'm talking about Elasticsearch in AWS, they have had to uh, limit the observability features that are available to customers, which make troubleshooting a lot harder. I don't need to do that. I'm just giving you everything that I have. It also means that in terms of dependencies, I'm not depending on any features that is available on just a particular cloud. It also means that I can say, oh, you know what? You are interested in running, I don't know, in non-cloud options, or oh, you just have a primitive cloud and only offer VPSs. I can run on that. A lot of the knowledge that I accrue from running such a system is absolutely transferable. I'm working at low level and the details are there. And less magic is absolutely a benefit. Less magic means that I don't need to understand how to manage that magic, and I can rely on my own system to manage that. And I would appreciate any questions that you have. I think we have about 5 or 6 minutes left. While I'm waiting for a question, there is a tab on the right that you can ask your questions, or you can ask them in the chat. I don't care which one. Uh, I want to explain and leave you with that thought. Not having to deal with unnecessary complexity is a huge win. And again, we are running on Kubernetes. You can run everything on Kubernetes quite easily. There is a sample on how to do that online. It's documented, supported, blah blah blah. But when we looked at what was actually required and what it cost us, the difference was just made no sense. Going, uh, it's funny, uh, bare cloud, I would call it this way, has been a great decision. By the way, we are now, I think, 3 or 4 years after that decision, and we had zero reasons to think that this was a mistake. It has proven itself to be a really good decision overall because everything is working, all of the support burdens are handled. For that matter, think about failure modes. Ravelry right now will provision you a cluster with 3 nodes in separate availability zones. If a node goes down, this happens. There are a lot of machines that we're running, node goes down. We can just speed up a new one. If you're using a cloud volume, then we just attach the appropriate cloud volume. We typically don't even need to do that, by the way. We can let the cloud do that. Shut down the instance, start the instance, and the cloud infrastructure will already provision that instance on a different physical host. This is completely transparent to me. I don't need to worry about that. Same things if I'm running on advanced or let's call it unique instances. If I have a user who want to run on NVMe with the highest level of IOPS because they have a quite busy system, I can do that easily, transparently. It gets funnier when you realize that Amazon introduced ARM-based instances. Everything runs on ARM, so we can just say, "Oh, let's shift some resources to run on ARM," and then everything just works. But we got a 20% reduction in billing because those instances are cheaper. Anyway, I hope you enjoyed this session. I think that I cover uh, everything, and I don't think there are any additional questions. So thank you very much, and have a great day.